Hey guys, Mr. B here, and in this video we're going to be going over density. Alright, so density is a very important concept in physical science and chemistry in general, and hopefully it's not something brand new to you and you've learned about density in the past, but this is going to be a little bit of a recap. So we'll talk about what determines density and how density changes with temperature. So what is density and how is it calculated? So density is the ratio of the mass of an object to its volume. The ratio means a fraction. So our equation for density is mass divided by volume. Mass is usually going to be measured in grams or kilograms. Volume will usually be measured in like milliliters, cubic centimeters, or liters. Now the easiest way to think about density is it's how much matter is essentially compressed into a certain amount of space. So things that are very dense can be small with a lot of matter tightly packed in together, and things that are not dense may be very large, but there's a lot of space in between all the particles inside of them. So here it shows three examples of 10 grams of a material with different densities and different volumes because their densities are different. So we have a 10-gram cube of lithium, which has a volume of 19 cubic centimeters. So it's relatively big, but its density is pretty low. So this has a low density because it has a large volume, and all the particles inside are pretty spaced out. 10 grams of water has a density of 1 gram per cubic centimeter and therefore takes up about 10 cubic centimeters of volume. So this 10 gram of water, the particles are a little bit more tightly packed together, therefore they don't take up as much space and they're more dense. Versus a 10-gram cube of lead. Lead is a very, very dense material, has a density of 11.4 grams per cubic centimeter. So this 10-gram cube of lead would be much, much smaller because the particles are very, very tightly packed together and therefore it has a very high density. Okay. Now, density is an intensive property. So to remind ourselves, that was something we learned about in the first chapter in this course. But an intensive property means that it is dependent on the composition of the material, not the size of the material. So this here has a table that shows just the different densities of a lot of different materials. Now you'll notice it does tell us density at 20 degrees Celsius. That is because density changes with temperature. So when we try to measure the density of a material, we typically try to do so at about room temperature and not at a really cold or really hot temperature because the density will change at hot or cold temperatures. Now, density is the reason why things float on top of other things. So if you've ever wondered, why does this material float in water and that thing sinks or vice versa, has to do with density. If the material is less dense than another material, then the less dense material will sit on top of the more dense material. So in this picture, it shows corn oil and corn syrup. Corn oil is less dense than corn syrup, so the corn oil will float on top and the corn syrup will sink to the bottom. And no matter how badly you try to mix these two materials together and stir them up, they will always separate back out because of their densities. All right, so let's talk about the last portion in here, and that is on density and temperature. Now, because density is essentially how much stuff is all packed into one little tiny amount of space, it does change with temperature, and here's how. So when you heat the temperature up of a material, okay, all materials are made out of atoms and particles, and those particles are usually kind of moving around together and they kind of vibrate, okay? Even though obviously at a large scale your eyes don't see these vibrations, the particles are moving, okay? Even in solids where they're packed together, they still jiggle around, they move. When you increase the temperature of a material, you're adding energy into that material. So these particles, which are kind of vibrating around, when you heat them up, they start to vibrate more and more and they start moving more. And this is what causes things to expand when they get hotter, okay? So if you ever warmed up a marshmallow before in the microwave, you'll notice that it puffs up and it gets really big. That's because the particles start to move around more, and as they do so, they start to space out, which increases the volume. Versus if you make something colder, instead of the particles moving around more quickly, they start to slow down and therefore they get closer together and they contract. So as you increase the temperature of a material, its volume usually is going to increase. And if you have a larger volume, that means that there's more space between the particles and therefore they become less dense. If you drop the temperature and everything gets closer together and more tightly packed, the density is going to increase, okay? So typically, the density of a material is going to decrease as its temperature increases, okay? So they're opposite. So temperature goes up, density goes down. Temperature goes down, density goes up. All right, so let's do some quick calculations just to see how this works. So it says a copper penny has a mass of 3.1 grams and a volume of 0.35 cubic centimeters. What is the density of copper? So this is a very basic density problem. We'll need to know what the equation for density, which is mass divided by volume. In this case, our mass is going to be equal to 3.1 grams. Our volume is going to be equal to 0.35 cubic centimeters. And so to find our density, we're just going to take 3.1 grams divided by 0.35 cubic centimeters, and then we will get an answer which is going to have 2 units. Okay, it's going to be a fraction, remember. So if we take 3.1 divide by 0.35, and we'll of course adhere to significant figures, we'll round to 2 sig figs, we will get 8.9 grams per cubic centimeter as our answer. Okay, and again, our units here are a fraction. Okay, so it's units of mass divided by units of volume. So this is our final answer here. Just a basic division problem, not too difficult. All right. Moving on, let's take a look at this one. What is the volume of a pure silver coin that has a mass of 14 grams? And the density of silver is 10.5 grams per cubic centimeter. So this is another density one, but now in this case, rather than asking us to solve for density, they're actually giving us density and they're giving us mass and they want us to find volume. So again, we'll need to know our density equation, which is mass divided by volume. In this case, we know that the density is equal to 10.5 grams per cubic centimeter. And we know that the mass is equal to 14 grams, and we just need to find volume, okay? So we can do this in one of 2 ways. One, we could just set up our equation for density and plug in the information we know, and then solve for what we don't know. So we have density is equal to 14 grams divided by V, which we don't know. We can do some algebra, solve for V. Or we can also do this dimensional analysis way. And the dimensional analysis way would be to do it this way. So we know that we're starting with 14 grams of material. Okay, 14 grams of material. If you want to put it over 1 to make it a fraction, you can. This here is a conversion factor. Okay, that's 10.5 grams over 1 cubic centimeter. We can use it as a conversion factor. So we're going to multiply by our density. But since we have 14 grams on top, we're going to need to take this density and flip it. So instead of having it as 10.5 grams over 1 cubic centimeter, we're going to have it as 1 cubic centimeter over 10.5 grams. Okay, and we're going to do it this way because now we'll see that the units of grams will cancel with each other. And we'll have the units of cubic centimeters as our answer, which of course is a volume. Now, again, either way, whatever you want to do to solve this problem, you're going to do the same exact math. If we do it this way, we do some algebra, we move some variables around, we basically get V is equal to 14 grams divided by 10.5 grams per cubic centimeter. Okay, this is essentially what we would get if we, again, if you move your variables around, if you know how to do algebra, this is the math that you'd get. And if we do it this way, in our calculator, we take 14 divided by 10.5. So again, we get literally the exact same answer, and the math you're doing is exactly the same. It's just 2 different ways to do it. So if you're an equation person and you really like equations and you're good at moving variables and doing algebra, then you can do it this way. If you like dimensional analysis, you can do it this way. I personally would recommend doing it the dimensional analysis way because even though this way right now seems easy, there will be problems further on where they get more challenging because there's more conversions to do than just simply plug in a variable and solve for one variable you don't know. So if you know how to do dimensional analysis, it does make your life a lot easier, okay? And if you're confused by dimensional analysis, just sit down with me. Okay, I promise you in 10 minutes I can make sure that you are a pro at it. It is super, super simple once you understand how to do it. So we're going to round this to one significant figure because of our 14 grams of our mass, which has only, two sig figs. I apologize. Round this to 2 sig figs because our 14 grams that we're starting with as a mass has only 2 sig figs. So we get 1.3 cubic centimeters. That is our volume. Okay. I believe that is it for the chapter of information here. It's a pretty short one. There are practice problems, of course, but there's a video of me going over those, so you can go watch that one on your own. Otherwise, that is it for this one, guys. I'm Mr. B. I'll see you in the next one. Bye.